7, 8, and 9, identifying functions from a relation. A relation is a set of ordered pairs, normally written as points, but might be written some other way. We want to decide, is our relation a function? In order to be a function, each value in the domain can only have one corresponding value in the range. So if I were to write this as ordered pairs, I would have the desk going to -8, paper also going to -8, the sun going to -8, and the rock going to -8. Each of my values only has one corresponding y value, or value in its range. It is going to be a function. Now the next one is an example of something that's not a function. If I were to write my ordered pairs, the cloud goes to S, but the cloud also goes to D. The cloud goes to S, the cloud goes to D. The star goes to C, the pencil goes to D, and the pen goes to S. But right here, because this value in my domain has two different answers in my range, it is not a function. So in order to be a function, each value in my domain can only have one value in its range. If I'm looking at my list of ordered pairs, if all the values of my domain are different, it's going to be a function. If something repeats and has two different y values, then it's not a function. So here, looking at this, -3 goes to -3, -3 also goes to -4, -3 also goes to 9, definitely not a function, because that -3 goes to 3 different values. Here the k goes to k, b goes to g, g goes to k, but then g goes to g, so the g is going to 2 different values, not going to be a function. So on number 8 again, if it is a function, each value in my domain can only have one value in my range. The sun goes to -9, however the rock goes to -9 and to 2. The rock goes to 2 different values, not a function. Here the moon goes to M, the tree goes to M, the door goes to M, the sky goes to M, the lake goes to M. Although they all go to the same thing, they each only go to one value. It is a function. Here, 2 goes to -1, -8 goes to -1, 6 goes to 2, -2 goes to 2. All of my values in my domain are different. It is going to be a function because they each only have one value that they go to. R goes to Y, S goes to Y, M goes to Y, Y goes to Y. That's kind of like this one up here. They're all 4 different. They all go to the same thing, but that's okay. It is a function because each value of my domain only has one corresponding value in my range. And number 9, this time they gave us our ordered pairs first. 4 goes to F, 4 goes to K, 4 goes to M, 4 goes to Z. Definitely not a function. The 4 goes to 4 different values in my range. 7 goes to -1, -1 goes to -1, 4 goes to 4, up, but -1 goes to 4. The -1 goes to 2 different values, not a function. K goes to C, R goes to C, N goes to X, X goes to C. Each of them only go to one value. It is a function. And here again, each of them all go to the star, but each of them only have one corresponding value. It is going to be a function. So for my relation, my set of ordered pairs, if it is a function, each value in the domain can only have one value in the range.